Okay, here we go. This is some practice problems. This is some. We'll go with it. These are some. There you go. First mistake of the lesson, right off the bat. Don't be afraid to make mistakes, people. I'm going to go through a couple slides. You've seen all these problems. This is just for resource for review. Here we go. Segments in each figure are tangent. Find each length. We know by the theorem that these have to be equal to each other. Second mistake, people. Be prepared. X plus 3 has to equal 2x. Therefore, when I subtract x from both sides, I get x equals 3. They want to know what BC is. Therefore, 3 plus 3 is 6. Simple. Here's one down here. These have to be equal, congruent, because they're tangent. Therefore, they must be set equal algebraically. Subtract 2y from both sides, giving us 3y. Wow. Get it together, dude. Can't be afraid to make mistakes, people. But I'm not doing another cut. First take every time. We don't do retakes here at Studio Parkinson. Can't afford it. Once the cameras are rolling, you got to go. Plus, this is better because our calculation works out a little bit better, wouldn't you say? Is everyone excited? RS 5 times 2 is 10. Okay, so what you want to do now is hit pause and solve these two problems on the right. And then I'm going to move the bricks. So if you pushed pause, there you have it. There's the answers. That was the two tangent theorem. Then we talked about arc length and sectors and measure and stuff like that. So we're going to go through this problem real quick. Remember, a central angle intercepts an arc of the same degree. So this has to intercept there. Therefore, this has to be 63 degrees. Therefore, this has to be 63 degrees. Now they want to know FGH. That's this guy right here. All right. Well, we know that that's a semicircle the whole way across. So that has to be 180 degrees. So 63 and 65 is 128. And when we subtract that from 180, we get 52, I think. Hopefully. Flying through it. Here we know vertical angles are preserved. So in there is 40 degrees. Yeah. We know this is 90 degrees. So if that's 90 and that's 40, that's 130. 180 minus 130 means this has to be 50. So BCD is 50 plus 90. BCD, which is 140. And, oops. And CDE, which is this arc, is 90 plus 40, which is 130. Get it together, dude. So this is 140. That's 150. Take a moment. You want to push pause and solve these two down here. And I'll move the brick. Boop. Okay. Hopefully you're back. If not, you're probably not learning if you haven't already. So moving forward. All right, here we go with chords and the arcs that they intercept. They tell you that line segment QR is congruent to line segment ST, so they must be equal in measure. Therefore, these algebraic expressions must be equal in measure. 4x, oh, geez, has to equal 3x plus 22. When I subtract 3x from both sides, I'm left with x on the left. And that's simply 22. They want to know what each measure is. Well, these are congruent, so 4 times 22, that's a 2, trust me, that is as well, is 88 degrees. This second one down here, number 9, is referring to the theorem where the radii is perpendicular to a chord, implies it bisects that chord. So those have to be equal in measure, right? Well, how do we solve this problem? We have to create our triangles. It tells us here that line segment LM is 10, which acts as a which acts as a radius. So that's got to be 10. That's got to be 10. We know that these have to be equal in measure, and you see a triangle there that's 10, 6. This has to be 8 because it's a 3, 4, 5 scaled right triangle. Therefore, NP is 8 and 8, which is 16. So now what you want to do is solve these two on the right, push pause, and when you get your answers, come back and I'll move the bricks. Boop. Boop. Next slide. So here we have sector area. We have to remember what the formula for area of a circle is, which is pi r squared. So here, read the directions. Find the area of each sector. That's the pizza pie piece or the cookie slice, whatever. We want 2 answers in terms of pi and then rounded to the nearest hundredth. So we know that the area is pi r squared times n over 360. So when you fill in the blanks, you have pi times 6 squared times 70 over 360, which is 36 pi times 1/9, which is 4 pi. And then rounded to the nearest hundredth, 4 times 3.14, whatever that is. 12.56, maybe? I don't know. Off the dome, people. Here we go. This one down here. Find the area of each segment. Okay, the segment is the area that's shaded, the pizza crust. Well, here we know that we want to do pi r squared n over 360 minus 1/2 base times height. That was the formula. Sorry, that's sloppy. So, we know that this is also 2 for our triangle. So we have pi 2 squared times 90 over 360. Wow, I really need a stylus. Minus 1/2 2 times 2. Which in the end becomes 4 pi times 1/4. Minus 4 over 2, which is pi minus 2, which is 3.14 minus 2, which is 1.14. All right. Take a couple minutes or a couple seconds and solve the two on the right. Push pause, and when you're done, come back and I'll move the brick. There are your two answers. This is all the way through 12-3. Come back for 12-4 and 12-5. Review over and out. Be safe.